To analyze the given algorithm, we need to know with which inputs and the algorithm takes less time, like performing well for the less time, and which input the algorithm take a long time. We have already seen that the algorithm can be represented in the form of an expression. That means we represent the algorithm with multiple expression, one for the case where it takes less time and the other for the case where it takes more time. In general, the first case is called the best case. So, the best case, that algorithm takes the least time. Okay? And the second case is called the worst case for the algorithm. To analyze an algorithm, we need some kind of syntax that forms the base for asymptotic analysis or notation. There are three types of analysis: the worst case, the best case, and the average case. Okay? So the worst case defines the input for which the algorithm takes a long time. This is the slowest time to complete. This is the worst case scenario. Input is one for which the algorithm runs the slowest. Okay, so worst case where the computer or the algorithm need the longest time or the slowest time to be completed. The best case defines the input for which the algorithm takes the least time. This is the fastest time to complete. So the best case is the algorithm that takes the least time to be accomplished. Okay? Average case provides a prediction about the running time of the algorithm. Run the algorithm many times using many different inputs that come from some distribution that generates these input. Compute the total running time and divide by the number of trials. Assume that the input is random. So this will varies according to the input and the generated things. And the average time, the average case is or the average time is varying between the lower bound and the upper bound. So the upper bound corresponds to the worst case, and the lower bound represents the best case. For example, if you have an algorithm that you write it to be accomplished in 1 second, so the lower bound would be 1 second, and you can make another algorithm that performs the same action in 10 seconds. So the least time is 1 second, so it is the lower bound. And the upper bound, which is the worst case, is 10 seconds. The average time is between 1 and 10 seconds, okay, for other algorithms. So the worst case is 10 seconds, and the best case is 1 second, okay? In the same way, for a given algorithm, we can represent the best, worst, and the average cases in form of expression. As an example, let f of n be the function which represents the given algorithm. So f of n that have n squared plus 500 is the worst case compared with the f of n that have n plus 100n plus 500. Similarly, for the average case, the expression defines the input in which the algorithm takes the average running time or memory. Remember, as n order, the n or the order of n in the function increase, the worsening or the algorithm speed to be executed will be decreased. So as we move in the order of n, and when we increase the order of n, like n to power 1, n to power 2, n to power 3, the worse the algorithm is going to be. Okay? As n order decreased, the algorithm the algorithm performance and execution is increased. Okay, so the least n order, the best algorithm you